when I think of sustaining engineering, one of the things that always comes to me is, you have a product, it's in production, it's been in production for a couple of years now. You've built and tested and shipped, I don't know, a couple thousand of these things, and all of a sudden there's a component inside the device that has gone obsolete. You get a notification from the supplier that widget, we're not going to make it anymore, and there's only so many in distribution. Um, get them now because the fire sale's over in a week, whatever it may be. So sustaining engineering, it's our responsibility to allow that product to continue in production, to still be able to be built for however many years our customer wants. So that widget that just went obsolete, it's now our job to find a suitable replacement, qualify it into the design, and then attest to any regulatory certifications, any testing and compliance that we need to adhere that widget to as it's used in the product. We need to do all of that work to make sure that that part is going to work in that situation in that product. But we take that responsibility on in order to sustain that product moving in production.
You can imagine in the past few years, I mean, we've spent, oh man, I don't know, at certain times it seems half of our engineering time is on sustaining engineering, redesigning printed circuit boards because an integrated circuit has disappeared, and the only one that fits is different, a different number of pins or something like that, or the circuit design needs to change because of the loss of a component. So we've gone through all of that especially in the past couple of years. It's been pretty crazy. So it's not all, oh, we have a last time buy on this component and we buy 2,000 of them and put them in inventory. I mean, that's kind of brute force way of, gee, that's more like sustaining purchasing rather than sustaining engineering. You just buy it, whip it into inventory. But that's expensive. It's much better if you can find a new part that's going to carry on, obsolete the old part, substitute the new one. At the same time, you got to watch out for spare parts, just in case now you've made something that's incompatible with previous units that you've made. You got to watch out for that and make sure that there's at least some assembly level that's backward compatible to the products that you've already delivered. It's not trivial, and every instance of something going obsolete sure sets a cat loose amongst the pigeons, I'll tell you. It's a contractual thing with the customer. And in a lot of cases, there are regulatory rules about how long you have to be able to support the unit in the field. I think that's where that 7-year number comes from. I believe that's in EU directive for certain types of equipment, and we happen to build those types of equipment. We've got to be able to support it for 7 years. So you ship your last one, the clock starts 7 years later, you still got to be able to support it. And then after 7 years, you don't have to support it anymore.
Mm-hmm.
So phasing support of the product out, mind you that the decisions on how to do it usually end up with our customer. Sometimes they want to support those products for longer. In some cases, they really want their customer to buy the new one. So they're not worried so much about the support. You can always buy a new one. You don't have to stay with the old one. Perhaps that's a reasonable way to solve that 7-year support issue. Here's a piece of equipment that does the exact same job. Yeah, you just need a new one. There are some customers that give us a design to build, and we can build it and ship it to them. And then if a part goes obsolete, you would think that it would be our customers' engineers that would jump on it and find a replacement part. But in many cases, we didn't do the design, our customer did, but those engineers aren't around anymore, or they're off on some other project, and could we sort it out? And it's a little bit more difficult since we didn't do the design work. We have to get up to speed on exactly what the inner workings of the product. But usually we can get in the middle of it and do a proper substitution of components to keep it meeting its performance specifications. We've done that in a couple of cases. And in a few cases, we've had someone call up saying, hey, can you help me? I've got this product. We've never built it. We've never seen it. But I can't get this component. Can you help me out? And we can do that as well. Typically, we'll find an alternate component that can substitute in and do the same job. It's a little bit more risky because we're that much less familiar with the product. So that's usually we're making suggestions of what to put in, and in some cases we'll make the changes and do some testing, and then turn it back to the customer so that they can confirm that the product's working exactly how they want it. And then we can let them know exactly what components to substitute or what the design change needs to be. In some cases, then they'll turn around and say, fine, can you just build it for me? Because it's easier for them to do that than roll those changes back to the organization.
One of the other things that kind of comes to mind too with sustaining engineering, we run into it in a few in a few instances recently, is we build a product and our customer will take responsibility of the software that goes inside this device. So they're off, doing whatever it is that they do to software, and then periodically they'll come to us and say, hey, we have an updated version of the software. We would like you to implement it on these systems starting here. Go ahead, roll with it. And what we've actually run into a few times is we get that new software, we put it into the system, but something to do with how we test it or how we interact with the device while we're testing it goes awry. Something is different about how we interacted with the equipment due to the software. The software team or the software isn't trying to hinder progress or anything like that, but sometimes things just get missed, and the typical way that we interact with a product now has to change,
right,
so that we can interact with that version of the software in such a way that will allow us to keep moving. So that part of sustaining engineering is there because we need to then go maybe tweak our process, tweak our manufacturing procedures, tweak our test procedures, tweak our test records for some other piece of information that needs to be captured. All of that goes into sustaining engineering. Again, it allows the product to keep moving due to a kind of an exterior circumstance that wasn't anticipated,
Mike's talked about when the software updates. Same thing, we'll get an engineering change request for hardware update, and we're adding a new feature, and that new feature affects the process to assemble it and affects the way it's tested and the record keeping, just like a piece of software would. So sometimes it's seamless. So here's a new release of the software and there's no changes to the process. All we need to do is record the fact that new software is installed. That hardly even counts as sustaining engineering. So it's almost transparent to us. We have to control the change, and we have to know serial number X went out with one version and serial number Y or X+1 went out with the updated version.
Yeah, we had one instance a couple of months ago where in order to interact with the device, we used to plug a USB keyboard and a USB mouse into the computer inside the device so that we could type stuff in and mouse around on the screen. Got a new version of software, loaded it up, and come to find out the software put a piece of code in there that locked you out of those two USB ports. So when we went to plug it in, we couldn't type and we couldn't use the mouse for anything. So we couldn't interact with the device in our current process. So we had to figure out a new way around it. We had to come up with some other way. I forget what we ended up doing, but we did. But it's all those little things, those little steps that you need to take to allow that product to keep moving in production.